Hello there! This video will show you how to do everything that you need to do in Microsoft Excel 2013 to answer the questions in your second Excel assignment. So just like last time, make sure that you save all of the work that you do in Microsoft Excel because you will be submitting your Excel workbook along with the answers that you fill in to the actual assignment itself. Now, we're actually going to be doing hypothesis testing in Excel, and in order to do that, we need to activate the Data Analysis Toolpak. Luckily, the Data Analysis Toolpak is a default option in Microsoft Excel, so it comes with the program. You just have to activate it using the steps that I'm about to show you. So once you open your Excel document, you'll click on the File tab. Then you'll go down to Options, so click Options. Then go down to Add-ins, click Add-ins. Then you'll find Analysis Toolpak, so just click that. Then you'll click this Go button down here, so Go. Make sure that Analysis Toolpak has a check mark next to it, and then click OK. And once you do that, once you click the Data tab up here, you will see the Data Analysis option right there. And that is the tab that we are going to be using to do our t-tests today. Now you'll also need to use the Data Analysis Toolpak for future Excel assignments. So if you use the same computer for the next Excel assignment, you should still have this activated. But if not, or if you use the same computer and you don't see this tab, you'll need to rewatch the beginning of this video to learn how to activate the Data Analysis Toolpak. Okay, so let's go ahead and look at the assignment. So the first page not only tells you, hey, make sure you're saving your work in Excel and you submit it. Also, it's telling you how to write results, statistical analysis results, in APA style. So this is a really important skill to have, not only if you ever do write or report results in a scientific way, so if you take a research methods class or something like that, but also if you're reading reports of research, it's important for you to understand what all these numbers mean and how to decipher the results. So I'm going to be very picky about grading on APA style. You need to italicize your statistical notation, you need to round to the thousands place, and you need to use the proper verbiage. And I gave you some pretty specific instructions for APA style on this first page, and you can also find instructions in your textbook, and I cited where you can find those instructions in the actual problem that asks you to write your results in APA style. Okay, so let's go ahead and look at the first set of questions. So this data should look pretty familiar to you, right? You've seen this before. Well, now instead of just like before, we just compared the means, right? We said, oh, okay, was the time management workshop effective? Well, it appears so because the GPA for spring was higher than the GPA for fall. And remember, they took the time management workshop between fall and spring. So we're like, oh, their GPA overall was lower before the time management workshop, higher afterwards. So we assume that the time management workshop was effective. But remember, you're going to expect a mean difference no matter what, right? The standard error. We're going to expect some sort of sampling error to occur. And the standard error tells you how much sampling error you would expect to occur. And remember, the standard error is based on the sample size. If you have a really large sample size, you're going to expect less differences due just to random chance between your means, and due to the standard deviation. So if you have a larger standard deviation in your sample, then you're going to expect any given means from that population to be more spread out. So remember, we don't want to just compare the means, the two sample means, the observed difference. We want to compare that observed difference to the difference we would expect to see just due to chance, in hopes that the observed difference is quite larger than the difference we would expect to see just due to chance, because the difference is actually due to what we manipulated, due to the independent variable, or in this case, due to the time management workshop. This is an important concept for you to understand for the rest of the class. We're comparing the observed difference, that observed difference due to sampling error and due to the independent variable, comparing that to just the difference due to error, in hopes that we have a large value, in this case for our t-statistic, which tells us that the observed differences exceed the differences we would expect to see just due to chance, because the differences that we observe aren't just due to chance, they're due to the independent variable, or in this case, the time management workshop. Okay, let's get to it. So kind of a similar scenario that we had before. Dr. Shinta wants to see if taking the time management workshop significantly improves GPA. Well, in the single sample t-test scenario, he is going to compare his sample GPA in the spring after they took the time management workshop to the population spring GPA, which is 3. So you see the little mu equals 3 there, to see if his hypothesis is supported. So in this case, his alternative hypothesis is that GPA improves after the time management workshop. Or in other words, that the spring GPA for his sample is significantly higher than the GPA for the traditional population of students that spring. So let's go ahead and do a single sample t-test in Microsoft Excel to get all of this information that Dr. Shinta needs to test his hypothesis. So first, let's go ahead and copy and paste our data. So remember, just go up to the top left corner of this table that has our data, left click, hit Control and C at the same time to copy, and then we'll go into Microsoft Excel, go to that first cell in your data set, hit Control V to paste. Unfortunately, Microsoft Excel does not have a single sample t-test option, but we can trick it into doing a single sample t-test by basically adding all the scores, or the mean for the population as a new variable, and doing a related samples t-test. So go ahead and click in cell C1 and type in population. And remember, the mean for the population that I gave you in the assignment was a 3, right? So the mean was 3 for the population, the spring GPA. So I'm just going to type in 3 here. And we're just going to fill this whole thing in all the way to the bottom with 3s. So I can type in a few 3s, then just highlight that whole piece, go to the Home tab, find the little fill option, click fill, and then down. And once you click down, it'll fill that in with 3s. So you don't have to type 3, 3, 3, 3, 3. Okay. Now let's go up to Data tab. So click Data. Then find that new Data Analysis option that we just installed. Click on that. And look for t-test to sample assuming unequal variances. Now you'll see there's 2 different options. There's the assuming equal variances, assuming unequal variances. I'm not going to explain what that means for now, but you'll see that when we talk about the independent samples t-test in a future lecture. So let's for now to sample, assuming unequal variances, click OK. So for variable 1, go ahead and select spring GPA, the whole thing including the label. So click the label spring GPA, hold down the shift key, and then just click in that last piece right there, that last value in your data set for spring GPA, and that highlights the entire column. You could also just click and then hold down the left mouse button and highlight, but I like doing the shift option. It's just faster, especially when you have a lot of data. Then click variable to range and just highlight all the population data. Leave hypothesized mean difference blank. It automatically assumes that we're expecting no difference under the null hypothesis, which is fine. Make sure you click labels so that Excel knows that the first cell in each column is the label for that column, so like spring GPA or population. And then we want to go ahead and have the t-test results displayed on a new worksheet. So make sure new worksheet is selected and go ahead and type in single sample t just to keep everything organized. Then click OK. Now before you do anything, go ahead and highlight all of your numeric values. So left click and just drag down. Then right click, go down to Format Cells and select Number and just have it automatically round to the thousandths place. So 3 decimal places. And then go ahead and click OK. Okay, now let's go ahead and edit this table so that the entire contents of the cell is displayed for all of these different cells in your table. So just go to the space between A and B. You'll see the double-sided arrow. Double click it. Go to the space between B and C. Double click. And then between C and D and double click. So that just auto fits the content, or auto fits the cell to the contents within each cell for each column. So now let's go ahead and copy and paste this into our assignment. So just highlight all of this, hit Control C, and then go into your assignment, and right under number 1, just hit Control V to paste it. Now, if you like to, shrink it and play around with the formatting for this, because watch, this can get crazy if you try to size it the way it is. Instead of pasting that way, you could, so let's go ahead and highlight that and hit backspace to get rid of it. Go down, make sure the Home tab's selected, see where it says Paste. Click on the little arrow below Paste, paste Special, and then let's go ahead and paste it as a picture, an enhanced meta file picture, and then click OK. Now we can size it so it doesn't take up so much room. So now I have all the values that I need to look at for my hypothesis test. And I'll go ahead and make this a little bit bigger so you guys can see it easier. So let me break down what's in this table. So the first row, the mean. So this is the mean spring GPA for our sample. This is the mean for our population. And of course it's a 3 because we just manually put in 3s for everybody in the population just to kind of trick Excel into doing a single sample t-test. Then we've got our variance, which is just the squared standard deviations here. So make sure when you put your standard deviation in your APA style write-up, right, you have to report the standard deviation, that you square the variance. Or sorry, you take the square root of the variance. Remember, the variance is the squared standard deviation. So to get the standard deviation from the variance, you take the square root of this value. So make sure you do that when you report it in APA style. Observations, that just tells you your sample size. We had 30 people in our sample. The hypothesized mean difference, remember the default was 0. Our degrees of freedom is 29. Remember, degrees of freedom equals n minus 1, so 30 minus 1 is 29. This would be our t observed, our t statistic. If we were doing the calculations in a hypothesis test, this would be the value that we compute in step 3. But now, this may be a little bit frustrating because you do all this work by hand, right? You're calculating all these things to find t, but in Excel, magical, click one button, bam, there's your calculation. But it's important to know how to do the manual calculations so you know how this number was derived. Now, what this value tells you, this t value, so this is what I'm asking for, number 2 is the t value. What this tells you is that the observed difference between the sample spring GPA and the population spring GPA is 5.079 times larger than the difference you would expect to see just randomly due to chance. So right now, what that tells me, this difference, the actual difference is much greater than the difference we would expect to see just due to chance, because the difference is probably due to the fact that the sample received the time management workshop, right? The difference isn't just a random sampling error. It's a difference that's due to the fact that the sample received some sort of independent variable, the time management workshop. Okay, so now let's look at our p-value and our critical values. So our p-value, these p's right here, and actually I'm just going to tell you we're looking at a one-tailed test, right? Because we think that their GPA is going to be significantly higher. So here's a nice picture of what we're looking at here. Here's our sampling distribution, right? Every single possible sample mean of 30 that could be taken from a population with a mean of 3. That's what we're looking at right here for our t distribution. And by looking at the p-value, this tells us the exact probability that we could get this sample mean from this population if we took a sample of 30. So remember, when we're doing hypothesis testing by hand, we're willing to reject the null, say that the mean is significantly different, or in this case significantly higher, if that sample mean has a less than 5% chance of being randomly selected from this population, even if the independent variable has no effect and the null hypothesis is true. Well, so in other words, our sample mean has to be in the extreme 5% of the distribution of all possible sample means, if that sample still represents the population, for us to say, yeah, that observed difference is much, much greater than the difference we would expect to see just due to chance. Or in other words, it's highly unlikely that we would get this sample mean from this population just due to random chance. So we probably got this sample mean because the sample doesn't represent the population. It's not a mean that we would randomly get from the population because we manipulated time management workshop, and now this spring GPA for the sample is from a different population, like a hypothetical population if everybody got the time management workshop. So if you visualize this, before we just found the critical value, which is in this case one-tailed test 1.699, and then we said as long as our calculated t, in this case would be 5.079, is higher than that, we can reject the null hypothesis. But in that case, all we knew is there was a less than a 5% chance of getting that mean randomly if the independent variable had no effect and the null hypothesis was true. Well, when you do this in Microsoft Excel, you get the exact p-value. So in this case, and actually because we rounded, take a look, the exact p-value, if we look in this, is 0.000001017 and on and on. That p-value tells us that there is less than, and let's go ahead and just say less than a 0.001 probability of type 1 error. Or in other words, there's less than a 0.001 probability that you would randomly select a sample mean of 3.437 from this population if the time management workshop had no effect. So we know not only that the probability of type 1 error or the probability of getting a sample mean that's this high just due to chance, not only do we know that that probability is less than 0.05 because our t crit exceeds, or sorry, our t stat, our calculated t exceeds our t crit, we know the exact probability of that happening, and it's super low. So when you report a p-value, which you will be doing in APA style, and your p-value when you round it to the thousandths place is less than 0.000, remember, you can see it in the instructions, you report it as p less than 0.001. So just throwing that out there as well. So we know it's extremely, highly unlikely, so rare, that we would get this sample mean just due to chance, that we think it's quite probable that we got this sample mean because the independent variable had an effect, because the time management workshop changed their GPA in some way. So we would be confident to reject the null hypothesis and say that the time management workshop did significantly improve GPAs. Now, instead of thinking about this conceptually, you can just use a simple rule to figure out, do you reject the null and say the findings were significant, say there's a significant difference or a significant improvement, based on the p-value. And that is, if the p is low, reject the ho. So remember the ho, the null hypothesis. If the p is low, if the p-value is less than the alpha level, then you can reject the null hypothesis and say there's a significant whatever, significant difference, significant improvement, significant decrease, whatever it is that you're looking at. So again, if the p is low, reject the ho. So you could simply say, I'm willing to accept a 5% chance of type 1 error, and there is less than a 5% chance of type 1 error in this particular study. So I reject the null, say that the time management workshop significantly improved GPA. That's a concept that students struggle with, but it isn't that complicated. It's just saying the same kind of thing we've been doing before. We want to know there's less than a 5% chance of randomly getting this sample mean if the null is true, the independent variable had no effect, and in fact that is the case. So not only do you know that because the p is low, here it's less than the alpha level, so this represents like probably not even part of this distribution, it's way, way, way off the charts, but you could also say, oh, my t-stat exceeds my t-crit, so I still know that I need to reject the null hypothesis. And it's always going to be the case that the decision you make based on p-value is the same as the decision you would make by comparing your t-stat to your t-crit. So that gives you everything that you need to answer these questions. So what is the value for the t-statistic? I gave that to you right here. And then what does that value tell you? I already explained what that value tells you in the video and in class. What is the p-value for this test? Well, I already told you what the p-value is right here, right? 0.000. And it is a one-tailed test. So I already gave that to you as well. That'll tell you what the critical value is, right? T-crit, 1.699 for this example. And then for this, I want you to tell me, explain to me how you know what decision you should make. So I already said we know that the time management workshop is significantly higher. We already identified that. But I want you to explain to me how you know based on the p-value and on the critical value. Then you need to write your conclusion in APA style. And I gave you an example of how to do that on the first page with some instructions. And you can also consult the textbook for detailed explanation of APA style and another example. So now let's move on to the related samples t-test. So instead of just comparing the spring GPA to the population to see if the time management workshop had an effect, we are going to compare the samples GPA before and after the time management workshop. So we're going to compare the fall to the spring. This is like what you did in the first Excel assignment, only now we're not just going to look at the mean difference, we're going to test the significance of that mean difference. So to do a related samples t-test in Microsoft Excel, let's go ahead and go back to the data. So you'll click on this little Sheet 1 tab at the bottom of your screen. And then under Data, make sure that you have Data Analysis. So click that. Then go to T-Test Paired to Sample for Means towards the bottom of those options and click OK. So for variable 1, you want to put the post-test results. So after the independent variable was manipulated. So spring GPA. So I'm going to click spring GPA, hold down the Shift key, click the last piece of data. Then for variable 2, you're going to select all of the fall GPA data. And it's important that you get the order of variables correct. So variable 1 is the post-test, variable 2 is the pre-test. Post-test is spring, pre-test is fall. So we looked at their GPA before time management workshop and then afterwards. Because this is like, if you think about the calculations for the related samples t-test, you have x2 minus x1. So in Excel, variable 1 represents x2, variable 2 represents x1, which is kind of confusing, but it's important to keep that straight because we're expecting an increase in GPA, not a decrease and not just a two-tailed test. So you have to be mindful of the order that you put those in because you want to make sure that if you get a positive value, that means that it increased in time 2 in the post-test. And if you get a negative value, that it actually decreased in time 2 or between the pre-test and post-test. Just like before, make sure labels is selected. Go ahead and leave hypothesized mean difference just blank. And then next to the new worksheet, make sure that's selected. Type T related samples. And then click OK. Now, just like before, highlight your numeric values, right-click, go down to Format Cells, go to Number, and then 3 decimal places out. And then click OK. And then we're going to do the double click trick so that we can get everything fitting in our table. So double click, and double click. And let's go ahead. And you know what? If you want to be really, really fancy, you can highlight all of that, go to the Home tab, and do Merge and Center. Woo, how pretty. Okay. Now let's go ahead and highlight all this. So highlight it, hit Control C to copy. You'll see the little happy dancing line that tells you that you've copied what you want. Let's go to our Excel assignment, and then let's go ahead and hit the arrow below Paste. You can hit Paste Special and do an enhanced meta file. Okay, so we've got our mean for our spring GPA and the mean for fall. In APA style, you're supposed to report the mean difference, and the Excel output doesn't actually give you that mean difference. So instead of having you do the calculations manually in Excel, you can go ahead and report the mean difference as spring GPA minus the fall GPA in APA style. Keeping in mind that if you had a more sophisticated statistical analysis package, you would actually get the true mean difference. But for now, just do the difference between fall and spring, and that's acceptable for reporting it in APA style. Then you have the variance for spring and the variance for fall. Keeping in mind that you're going to be reporting the standard deviation of the mean differences in APA. So to do that, you need to take the square root of your variances and then find the difference between those two. So you'll have the square root of this variance minus the square root of this variance. And that's what you'll report as the standard deviation of the mean differences, or the standard error of the mean difference in your APA style write-up. This is kind of like a good enough for now type of thing because, again, Excel doesn't really give you that value. If you were using SPSS, for example, you would have that value. Just know that in APA, you're reporting the mean difference and the standard deviation of the mean differences. And that's how you'll do that. So again, for mean difference, you'll subtract fall from spring GPA. For the standard deviation of the mean difference, you'll square root these, and then you'll do the subtraction there. We have observations. So we have 30 observations, sample size of 30. Here's this thing, the Pearson correlation. I'm not going to really go into too much detail about that now because you'll learn about that in a future lecture. But for now, just know that this indicates there's a strong positive relationship between the two, but that's not really sensical for this particular example. So just ignore that. Hypothesized mean difference, remember the default is 0. Degrees of freedom, n minus 1, 30 minus 1 is 29. Here's our T-stat. So what this tells us is that the observed difference between spring and fall GPA is 4.85 times larger than the difference we would expect to see between these two sample means just due to chance, even if the time management workshop had no effect and the null hypothesis is true. So pretty substantial. Then here's our p-values again, right? So we kind of have the same situation that we had before. Not only do we know that we can reject the null hypothesis and say that GPA significantly improved, because we know that the t-stat exceeds our t-critical. So if we look at this picture again, our our t-stat of 4.85 is greater than our t-crit of 1.699. But also, there's a really, really low probability that you would randomly get this sample mean difference just due to chance. So it's likely that that sample mean difference is due to the independent variable. So again, now we've got a p-value of 0.000, and that exceeds, or that falls into this critical region, right? It's less than our alpha level. So the probability of getting the sample mean difference is way less than 0.05, less than a 5% chance of type 1 error. Our p is low, so we reject the HO and say that there is a significant improvement. So that gives you all the information that you need for what is the t-statistic, what does that value tell you in plain English, what is the p-value, right? P-value is 0.000, so essentially there's a very unlikely chance of type 1 error. It's highly unlikely that you would get this sample mean difference just due to chance, so that difference is probably due to the independent variable. You know what your critical value is. I already told you it's significant. I just want you to explain to me in your own words how you know based on the p-value and comparing your t-stat to your critical value. And then use the guidelines that I set forth in the page 1 to write the conclusion of this t-test in APA style. And you can also consult the textbook at these pages, depending on the edition that you have, to figure out how to do that as well. So I hope that this was really helpful for using Excel and also for answering these questions and understanding t-test just a little bit better than before.